Hello everyone. We'll now start the last topic of probability. Now, this particular topic is completely new and very foreign to whatever we did till now. We'll be starting probability distribution. So, when we hear the word distribution, we already heard it in the previous three chapters. We talked about in statistical description of data, frequency distribution. We talked about in central tendency, mean, median, mode, dispersion, and all, where we had table. That table was basically where we wrote the frequency for all the numbers, was known as frequency distribution. So now we are talking about probability distribution. That means we are again going to have a table, but this time in the table, instead of frequency, we'll be having probability. So in order to understand that, see, when we talk about frequency distribution, you need to have frequency for someone. Suppose, what is the frequency of getting marks between 0 to 10? Or what is the frequency that your height is between 5 feet to 5 feet 5 inch? So you talk about certain parameter, right? Similar to here, in order to find probability distribution, to talk about probability distribution, to talk about probability of something, that something will be for us random variable. Okay, we'll be talking about random variable. First understand, then we'll write. Now, what is a random variable? Since it's a variable we denote it by letter, we'll only denote it by capital X, no other letters are allowed. Now, it's variable, so it does not have a fixed value. The value may vary, obviously. Now, what happens here is, it is basically a real valued function. Now, what is a function? Like x square. I give an input 1, it in return it gives me another output 1 square 1. I give an input 2, in return it gives me 2 square 4 output. So you give an input, in return you get an output, and hence you form a pair. 2, 4 is a pair, 3, 9 is a pair, 4, 16 is a pair. You form pairs. Similarly here. Now, since we have random variable, what will happen here is, it is going to form pairs. How will it form pair? There will be a condition written in the question. Okay, there will be a condition written in the question. For example, I'm talking about 2 coins. So if I'm talking about 2 coins, what will be my sample space? HH, HT, TH, TT. I'll have 4 outcomes and this will be my sample space. Agree? Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
So now the criteria will be X. The question will tell you, okay? It represents number of heads. It represents number of heads. The question will always tell you. So now what will this do is, so what does random variable do? It's a function, so it will form pairs. It is going to have an input and it will have an output. So inputs are always sample space. We start from sample space. Now, all the elements that are present inside the sample space, I'm going to ask the same question for every number. For example, I talk about HH. For HH, what will be the corresponding value of X according to this criteria? In HH, how many heads do you have?
2.
2. So here the value of X will be 2. In HT, how many heads do we have?
1.
1. In TH, how many heads do we have?
1.
1. Again, same number. In TT, how many heads do we have?
0.
0. So what we do is, to every number, we'll only assign one answer. But the same answer can also be given to someone else. It's not that the same answer cannot be shared. The same answer can be given, like here, we gave the same answer 1 to 2 different elements. You can do that. But one number, one element will get only one answer. So if I have HH, I can only give one answer. If I have HT, I can only write one answer, whatever that answer may be, but only one. So what values are allowed? Any real number is allowed. In your answer, you can have decimals, you can have fractions. The value of random variable X can be anything. For example, right now I'm counting number of head, number of tail. Obviously, it will be whole number, natural number. But if I talk about amount, suppose you have gambling, okay, or playing poker, whatever. So at that time, your money can be in, I won, for example, 550.5 rupees. Possible. I lost 2.1, 2.5 rupee. It's possible. So at that point, it can also be in decimals. Okay. So the value of random variable can be any real number, positive, negative, zero. It can be anything. Okay. Now, here, in case of random variable, since it's a function, what is a random variable? Since it is denoted by, please write, denoted by capital X, it is a real valued function. Now, if we have already done the chapter function, so in function we have domain and range. Domain is the first set, range is the second answer set. So domain of random variable will be sample space. It always starts from sample space. Range will be some real numbers, subset of real numbers, subset of real numbers. In this particular example, this is my domain. This sample space is my domain. What is my range? Range of X or values of X are the answer that I got. What answers did I get? I got 2, 1, and 0. That is my range. I could have got -1, I could have got -2, I could have got many more, right? But I only got these three answers. So that is my range. So domain, sample space, range, subset of real numbers. Agree? Yes, ma'am. Any doubts, guys, still here? No.
No, no.
No, ma'am.
Okay. Now, this is your random variable. Now, if I write all these values of X, with that, correspondingly, I'm also writing their probabilities. Now, think, how will I write? I'm finding probability that X will take the value 2. Now, you tell me, when is X taking the value 2? When we have HH, right? What is the probability of HH?
1/4.
1 by 4. So probability of 2 will be 1 by 4. Now probability of 1. So X will be 1 when we have HT and TH, right? So what is the probability of getting HT or TH?
2/4.
2 by 4. Then for 0, for 0, for 0, what will happen for 0? 0 is TT. What is the probability of TT? 1 by 4. Any doubts?
No, ma'am. No, ma'am.
Okay, so this box is known as probability distribution of X. This box is known as probability distribution of X. Okay, now there are two conditions that has to be satisfied. First, see, there are no restrictions on the values of X. X can be any real number, positive, negative, fraction, zero, everything is allowed. The first column can be anything. The second column, the probability one, the probability row, that can only be probability, or you also write sometimes PI, has to be greater than equal to 0. Obviously, common sense, it's probability, it can't be negative. And sum of the probability will be 1. Sum of the probability will be 1. These two conditions have to be satisfied for in the probability distribution. Okay, so what is random variable? It is a real valued function. What does it do? To every element of the sample space, it assigns a real number. To every element of the sample space, it assigns a real number. That can be anything, fraction, decimal, zero, anything. Now, the box in which we write every value of X with its corresponding probability is known as probability distribution, provided it satisfies two conditions. First, all the probabilities has to be non-negative, that is greater than or equal to 0. And second, sum of the probability has to be 1. When both of these conditions are satisfied, we say that it is a probability distribution. Understood?
Yes, ma'am.
Now, all the concepts, mean, median, mode, that means central tendency ones, dispersion ones, standard deviation, all those, everything is valid here. All of the concepts are valid here. So, when we want all those concepts here, mean, for example, I want to find mean. So, expected value of x, e of x, also known as mean, also denoted by mu. This is summation x into p of x. Sum of the product of every number with the corresponding probability. So, in this example, what we will do is first 2 into 1 by 4 plus 1 into 2 by 4 plus 0 into 1 by 4. Answer 4 by 4. So expected value of x. So they'll ask you what is the expected number of heads. That means heads is the criteria for random variable. You first form a box for head, and from that box you find out the expected value, also known as mean. How do we do that? We multiply every value of x with its corresponding probability and add all of them. Again, the mean can be positive, negative, anything. Okay. So this is the only formula for mean. Now, if I say e of x square, there is no name for this. It is summation x square into probability. Okay. That will be 2 square into 1 by 4. Square is only the terms. Probability is not getting squared. Okay. Plus 1 square into 2 by 4 plus 0 square into 1 by 4. Done? Answer
6 by 4.
3 by 2. If I ask you E of x cube, if I ask you E of x cube, it will be x cube into probability. If I ask you E of x power 4 into probability, probability will remain as it is. Okay, only the x part varies. Clear?
Yes, ma'am.
Okay.
Yes, ma'am.
We have variance of x. There are two formulas, x minus mean whole square. Instead of mu, we could have also written E of x. Mu and E of x are same. Mu and E of x are same. But in order to do the sums, we will be using E of x square minus E of x whole square. To do the sums, we'll use the last one. And standard deviation of x, it is root over variance. So same formula with root. All the same formulas, but just with the root over. So variance and standard deviation, we know it's a part of dispersion, right? And dispersion values are never negative. So here also standard deviation and variance cannot be negative. Mean can be any number. So in the same example that we did, if I want to find out variance of x, I'll use the formula E of x square minus E of x whole square. E of x square was 3 by 2. E of x was 1. So answer would be half. If I want standard deviation, it will be root over 1 by 2. Is it understood?
Yes, ma'am.
Yes,
Now we'll talk about 3 coins. So first everybody write the sample space for 3 coins. Write the sample space for 3 coins. sample space, H, 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 T, H, T, H, H, T, T. Eight outcomes, basically. You should have 8 outcomes written. So suppose I asked you find the probability distribution of number of tail. Find the expected number of tail. That means I'm telling you that your random variable is number of tail. Okay, we'll always give you a hint. So random variable will be number of tails. So HHH, how many tails? 0.
0.
HHT,
One.
1. HTH,
One, ma'am.
HTT,
Two.
TTT,
D.
3.
THT,
2.
TTH, THH,
1.
1. So what are the possible values of X we can see? 0, 1, 2, and 3. Only these 4 values. Now write their corresponding probabilities, all of you. Write their corresponding probabilities. Written?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So for 0,
1 by 8.
1 by 8.
1,
3 by 8.
3 by 8.
2,
3 by
3
8.
by 8.
3.
1 by 8.
Thank you. So now find E of X, which is mean.
Twelve by 8.
12 by 8. 1.5, that means. Find out E of X square. X square into probability. 0 square into 1 by 8. 1 square into 3 by 8. 2 square into 3 by 8. Plus 3 square into 1 by 8.
24 by 8.
3. So what will be variance of X? E of X square minus E of X whole square. Answer 1.5.
0.75.
Acha, sorry. My fault, my fault, my fault. 0.7. Standard deviation will be root over variance. How much?
0.866.
0.866. Got it?
Yes, ma'am.
Yes, ma'am.
Now, there are several formulas of smaller properties. First, expectation of any constant. If there is no X, it will remain the same. That is, expected value of K will be K. There is no X. Standard deviation of a constant or variance of a constant would be 0. If all the observations in the data are same, then mean will also be the same number. But standard deviation and variance will be 0. Second, expectation of x plus y. It will be E of x plus E of y. Expectation of constant into x. So E only goes to x. Expectation of x into y. It will be expectation of x into expectation of y. Now, expected value of a, x plus b. A and b are constant. So E only goes to x. Now, what do I mean from here? See here. You already obtained expected value of x as 3 by 2. If I now ask you what is the expected value of 2x minus 5, it will be 2 into expected value of x minus 5. Put the value of E of x that you have already calculated. 2 gone. Answer would be minus 2. So for whatever equations we are finding out, just put right E for that. If I write expectation of 1 plus 3x, E will only go to x, rest everything will sit at its place. So 1 will remain 1, 3 will remain 3, E will only go to x. And E of x we have already calculated here, 3 by 2. Put that value. So 1 plus 9 by 2, 11 by 2. Everybody understood?
ma'am.
Yes, ma'am.
Yes,
No.
ma'am.
But it's not same for standard deviation and variance. Standard deviation of this will be whatever you add or subtract, change of origin doesn't matter. So anything that you have added or subtracted, that goes away. The only thing that will remain is multiplication. And also you can't have a negative answer. So it will be absolute value. So if standard deviation of x is 3, then standard deviation of 1 minus 2x. So whatever you have added or subtracted, that goes away. The only thing that will remain is, suppose it is divided by 5. Whatever remains is the thing that you have multiplied and divided. So x is multiplied by 2 divided by 5 into standard deviation of x. You don't write the negative sign also. Because standard deviation and variance can't be negative. Now you put the value of standard deviation 3. So answer is 6 by 5. In variance, again, whatever you add or subtract, it doesn't matter. That will again get vanished. But whatever you have multiplied or divided, that will get squared. A square into variance of x. If variance of x is 3, then variance of 2 minus 5x would be 5 square into variance of x. So 25 into 3, that is 75. Everybody understood?
Ma'am.
Okay. Try the examples from 15.27. From 15.27, page 15.29. Okay. Question number 15.27 is the 3-point question. We have already done that. 15.28, the box is already written here. From that, we first find E of x, summation x into probability. 0.4 into 1.5, 0.15 plus 5 into 0. That is 6.60. We find E of x squared, summation x square into probability.
What is
6.6, ma'am.
1 second. What is 6.6? Now, the question asked us expectation of x minus E of x whole square. This is basically variance. We use this formula E of x square minus E of x whole square. So 46.6 minus 6.6 whole square. 3.04. This is variance. What else is there? Also obtain variance of 3x minus 4. So 3 square into variance of x, whatever is added and subtracted, that is gone. So 9 into this, that is 27.36. What the answer? Hmm? 15.29. In a business venture, a man can make a profit of 50. See, whenever question comes for rupees, for amount, for money, X is money. No matter what it says. X will always be money. So we are talking about profit loss, so money. So X will represent money. So profit, so plus 50,000 and loss 20,000. Loss is negative. Making a profit, the probability is 0.75, loss is 0.25. Expected profit, expected value, summation x into p of x. 50,000 into 0.75 plus minus 20,000 into 0.25. 32,500. Guys, did you get the answer? Yes, no.
Yes, ma'am.
15.30. A box contained 12 electric lamps, of which 5 are defective, 7 are good. A man selects 3 lamps at random. So if you select 3 lamps and you are asking me to find expected number of defective lamps. So X represents number of defective lamps. So if you have chosen 3 lamps, you can have 0 defective lamp. You can have 1 defective lamp. You can have 2 defective lamp. You can have all the 3 defective lamps. That's all the possibilities that I can have. Now we need to find probability. So we are talking about selecting 3 lamps. So denominator will be 12C3 for all of them. Now 0 means 0 defective. That means all the 3 are good. So 3 good will be 7C3. 1 means 1 defective. So remaining 2 will be good. 1 defective 5C1, 2 good 7C2. 2 means 2 defective, 1 good. So 2 defective, 5C2, 1 good, 7C3. 3 defectives, so 5C3. Calculate 7C3. This is 105 by 220. 70 by 220. 10 by 220. What we wanted is expected value, E of X. So 0 plus 105 by 220 plus 140 by 220 plus 30 by 220. Add and tell me how much. One point two five. Answer,
275 by 220.
which is
1.25.
in this.
1.5.
Very good. All of you got the answer?
Yes, ma'am.
Yes, ma'am.
Thank you. 15.31. Model draws 2 balls from a bag containing 3 white and 5 red. He gets rupees 500 if he draws a white ball. For white ball, he gets rupees 500. For red, he gets 200. So X will be money. X will be money. What is his expectation if he is asked to pay rupees 400 for participating in the game? So if he's choosing two balls, you can write anything. You can choose white ball, you can choose red ball, whatever you wish, doesn't matter. Suppose X is white ball. Okay. So if you are talking about selecting two ball, it can be that both are white. It can be that one is white. It can be that zero white. So 2 means there are two white balls. 0 means one white. So remaining one will be red. 0 means zero white. So obviously both the balls are red. Yes, no. Probability. Since you're selecting two balls, total will be 8C2. So two white will be 3C2. One white, one red. Zero white, so both of them are red. So answer this will be 3 by 28, 15 by 28, 10 by 28. But we said that X will be money. So if I have two white ball, how much money will I get? I'll get 1000 rupees. If I get one means one white and one red. So 500 plus 200, I'll get 700 rupees. Zero white, that means both red. So I'll get 400 rupees. So these amount will have corresponding probability. So we first find expected value. ₹625. And it said that in order to play the game, we had to pay 400. So even if I remove my participating fees, I still have a profit of 225 rupees. That means, should I play the game or not? Yes, I should definitely play the game because there are more chances for me to take the money home. It said that for participation, I need to pay 400 rupees. So I am expecting on an average to win 625 rupees. So it covers my participating amount also. So even then, I'll be at a profit, right? So we should play the game. 400, then it doesn't matter whether you play or not. It's both equal chances. If it comes out to be negative, then you should not play. Done?
Ma'am, can you explain how you got 625 alone?
1000 into 3 by 28 plus 700 into 15 by 28 plus 400 into 10 by 28. Summation x into px. Right?
Thank you, ma'am.
Did you get it in your calculator?
Yes, ma'am.
Okay. 15.32. Learn. Learn the sum. 15.32. I'll give you a hint. You need to learn this. So it says number is selected at random from a set containing the first 100 natural numbers, and another number is selected at random from another set containing the first 200 natural numbers. What is the expected value of the product? Expected value of the product is E of X into E of Y. So I'll find out their individual expectation and I'll multiply. So first, if I'm selecting a number from the first 100 natural number, my number can be 1, 2, 3, 4 till 100. And probability for each number to appear will be 1 by 100 because there are 100 numbers and each number will have only one check. Any doubt till here? So expected value of X will be 1 into 1 plus 2 plus 3 into 1 plus 4 up to 100 divided by 100. So we can use mean formula. N by 2 first term plus last term. 100 gone. 101 by 2. Yes. Similarly for Y, we can select any number from the first 200. So this time it will go till 200 and probability to get each number would be
1 by 200.
1 by 200. E of x, again multiply. So all of them has the same denominator, 1 plus 2 plus 3 till 200. So 200 by 2, n by 2 first term plus last term. 200 cancelled, 201 by 2. So expected value of the product would be E of x into E of y. So 101 by 2 multiplied by 201 by 2. 5075.2. Any doubt?
Ma'am.
15.33. A die is thrown repeatedly till a 6 appears. Write the sample space. So it can never come because it's an MCQ question. They can never ask us to write the sample space. Find the expected number of throws. So if I'm throwing the dice, it can happen that I get 6 in the very first game. I'm so lucky. So suppose I'm saying P is 6 appears, Q 6 does not appear. So X 1. What does X number of throws? Na? So X will represent number of throws. So it may happen that I threw it for the first time and I got 6. Yes or no?
Yes, ma'am.
X represent the number of time I have thrown the dice. It will go till infinity. It starts from 1. I can win in the first game. So X is 1 right now. What will be the corresponding probability of you getting 6 in the very first game?
1 by 6.
1 by 6.
I may get 6 in the second game. So why did I play the second game? Because I did not get 6 in the first game, right? Otherwise, I would not have played. So what will be the corresponding probability? Not getting 6 in the first game and getting 6 in the second game. So in the first game, you did not get 6. Probability.
5 by 6.
And then you got 6. So 1 by 6. Yes, no.
Yes, ma'am.
Third, you won, you got 6 in the third game. So in the first 2 game, you did not get 6. And then you got 6 in the third game. And it continues till infinity. Expected value of x. Sum of x into p of x. 1 by 6 plus 10 by 16, 36 plus 75 by 216 and so on. Now, this you cannot calculate. You have never learned this. Yes, learn the answer. Guys, learn the answer. Instead of 6, 4 appears, 5 appears, 2 appears, doesn't matter. Answer is always going to be 1 by 6. 6, sorry. My fault. My fault. Answer is always going to be 6. Always. 15.34 is a very common question. Read. And random variable x has the following distribution. But in the distribution, they have given us k. What do we know about the conditions of the distribution? What are the 2 conditions it has to satisfy? Sum of the probability has to be 1, right? So sum of the probability is 1. So if you add all the probabilities, how much will you get? 10k square plus 9k equals 1. You'll have several values of k to do trial and error from. Do the trial and error. Okay, you can do the trial and error here. I'll give you the options. K is 1 by 2. K is 1. Can k be 1?
No, ma'am.
Can k be 1? No, because
No.
in some cases I've written 7k square. So how can the probability be 7? So this is wrong. Again, k is written in probability. It cannot be negative. It's wrong. So the only possibilities are A and D. Only possibilities are A and D. Do trial and error.
D, ma'am.
D, ma'am.
K is 1 upon 10. Understood?
Yes, ma'am.
Yes, ma'am.
Then it asks us, second, probability x smaller than 3. So x smaller than 3, that means x can be 0, 1 and 2. Add their probabilities. Probability of 0 plus 1 plus 2. That is 5k. Now put the value of k, that is 5 by 10. Third, probability of x more than equal to 4. So we can take from 4, 5, 6 and 7. Add all of them up. 10k square plus 3k. Put the value of k 1 by 10. So 10 by 100 plus 3 by 10. So 0.4. Last, probability 2 lesser than x less than equal to 5. What values am I allowed?
3, 4, 5.
3, 4, 5. 2 is not allowed because we don't have an equality in 2. 3, 4, 5. Add them up. 3k plus k square. Put the value of k. 3 by 10 plus 1 by 100. Answer 0.3. All of you got the answer? All of you got the answer?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
That's it for probability. I'll ask you all to do the module questions, the backside questions. Okay? It should be pretty easy for you all to do it. 1 or 2 may be difficult, otherwise you should be able to do it. Okay? We shall discuss it in our next session.